As you heard, my name is Goran Milić, and I'm not the designer nor architect. Sorry about it. Today, I will try to explain how a forgotten byproduct from wood industry, from wood steaming, can become a natural textile dye and some more things. In other words, to explain how to turn waste into value, just are small steps towards circularity. Why wood waste matters? Just to clarify at the beginning, I put wood waste here also in the title of the presentation, but in our industry, in the wood industry, we don't use that term. We use the term wood residues or wood residue because almost everything can be used. It's not a waste. As you can see, EU wood industry, there is a lot of it. EU wood industry generates over 40 million tons of residues every year in different forms, such as, just to check, okay, same problem as you, yeah, in a form of bark, in a form, a lot of sawdust, wood chips, wood shavings, and also in bigger form like wood offcuts. Much of this material is still burned for low-grade energy. Although this heat energy makes wood industry self-sustainable, I still see a huge chance, circular economy chance for at least these bigger parts, wood offcuts. Also, there are much less known residues or byproducts from this industry. I will talk about it later on, but because you are not familiar probably, I will just briefly explain this journey from forest to furniture. We are starting in forest, of course, with logs. These wood logs are coming to a sawmill for debarking and sawing into timber or sawn wood. This sawn wood is entering hydrothermal processes. The major one is kiln drying. It is the process in which we are reducing moisture content of wood to a level to a level at which it will be in equilibrium with the surrounding air in the spaces where wood products will be used. For the interior, this is approximately 8% of moisture content. So we are reducing moisture content. This is especially important process because it is the most energy intensive and time consuming process in the whole chain. After that, we are entering this secondary process or manufacturing with a lot of different cuts in different ways. Also planing, pressing, all other machining in order to get any final product, in this case, furniture. As you can see from this slide, in almost all parts of the process, we are having residues, like here, bark, or wood chips and sawdust, but also a lot of, in this part, sawdust, shavings, soft cuts. The only exception is this kiln drying. However, for some wood species, there is another process of hydrothermal treatment called wood steaming. It is positioned somewhere here, just before kiln drying. Now, I will say a few words about it. It is a process in which we are exposing wood in chamber like this one to a saturated steam. The temperatures are between 90 and 100 degrees. So a little bit, the atmosphere is like a Turkish bath, just with much higher temperatures, 90 to 100. And we are producing steam usually like this. We have a channel in the floor of the chamber. It has a heating coils. We fill it with water. The water is boiling and producing this steam atmosphere. Duration of the process is usually 8 to 48 hours, depending on the species, and for some wood species, it's much longer. In industry, you have been in gear, I think, maybe you have seen it. In industry, capacity of steaming chambers is usually between 20 and 40 cubic meters. You can see the photo of the chamber packed with timber. And finally, the goal, of course. The goal of steaming is color change, mainly darkening of wood, but also for some wood species like walnut, the goal is to reduce the difference in color between different parts of wood. Some additional benefits are also reached, like wood sterilization and reducing of growth stress. So quite an important process. Wood species that are usually steamed are beech, the most important European wood species. It can be steamed light or dark color. Just to illustrate, this is the example of unsteamed beech. And this is light steamed in short process of steaming. So a little bit darker and, let's say, reddish color. But also some other, not so important, like black locust, walnut, cherry, mainly hardwoods are steamed. The rule of thumb is the longer the process, the darker the color. That was about steaming, but the important thing here is that during the whole process, this steam in contact with wood and the roof and the walls of the chamber, it condenses into and turns into a dark brown liquid. It drains into that channel in the floor, and then from the chamber. The color of that condensate, we call it that liquid, we call it wood steaming condensate. The color of that liquid depends on wood species, on duration of the process, and the type of the process. For example, here, this is the wood condensate from walnut. But the walnut is steamed 96 hours, so 4 days. So it's a much longer process. This dark color is not only because of walnut, but also because of that durable process, long process. And this one is from beech, but only after 12 hours of steaming. So the color can vary between this orange and dark brown. This again, some samples from walnut condensate taken for testing. The important thing, one single industrial cycle is producing 1 to 10 tons of condensate. It is usually treated as wastewater and discarded. And just to illustrate the amount of the condensate, only in Serbia, we have around 200 companies that steam timber. Some of them steamed beech, often hundreds of cycles per year. And again, in each cycle, 1 to 10 of condensate. So we have a plenty of it. If you have any idea, we have it for you as well. What's inside this liquid? It's quite rich, chemically, it's quite rich mix of phenolics, of sugars, and mild organic acids. It's naturally pigmented. So this dark color is only from wood. It contains only wood extractives. No additional chemicals are added during the process. And we did a lot of tests, and it was clearly demonstrated that it has high antioxidative and antimicrobial properties.
Sorry, and the color is the combination of these phenolics, sugars, and organic acids?
Yeah. Yeah. And now something completely different. For these nice colors, I think that we as a humankind or society are paying a high cost. This is the dark side of textile dyeing. It accounts for about 20% of industrial water pollution. In general, maybe someone is familiar with it, in general, textile has a lot of environmental problems and high footprint, really high. And probably the most problematic part of the whole process is dyeing of the textile. In numbers, just to explain, dyeing of only 1 kilogram of fabric usually consumes approximately 140 liters of heated water, 250 grams of chemicals, including 40 to 50 grams of synthetic dye, often heavy metal based. And it goes clearly with significant environmental and health risks. For example, really high greenhouse gases emissions, hazardous wastewater, food with heavy metals and aromatic compounds, and finally, toxic chemicals in dyes can cause skin irritation and also long-term health risks, both for workers and consumers. So our solution goes like this. This is the wood industry line that I explained already. So we are starting with logs, timber, steaming. This steamed timber is used for producing furniture, like this armchair. And as I said, huge amount of condensate, and we are using that condensate to dye textile at room temperature. It's important at room temperature. This fabric that can be further used, of course, in fashion industry, but also for textile in upholstered furniture industry. In that sense, we have this nice loop here. So the important things are we are doing in cycles. We are using condensate few times in order to have cleaner wastewater. We are adding no chemicals, and as I said, we are doing it at room temperature. So our, let's say, big fives are reduced use of synthetic dyes, reduced water consumption because condensate is mainly water, lower wastewater pollution, energy saving. As I said, we are doing at room temperature, no heating, and as a bonus, we have these antimicrobial properties built in the fabric. About the colors, this is the palette usually. We can change if we add something, but originally something like that. So let's say earth-inspired tones, this matte finish, soft feel, and of course I'm not a designer, but to me it pairs really well with this slow fashion aesthetics of natural materials like wool, for example. And we are looking forward also to do some tests on the textile which is produced from wood. It would be also a nice circle. This is just a reminder for myself. We are not on the market, so we are still in the lab tests, but hopefully I'm expecting till the end of this year to do some trial tests in the companies. So hopefully it'll be prepared for them. And if I have 2 more minutes, yeah. Just to tell you, as I said, we have plenty of it, so we are trying also some other things to do. For example, we are using condensate for producing greener wood panels in a way that we are blending condensate into UF resin. It's a resin which is typically used for wood panels, for particle boards, for example. We are blended into that resin instead of water in order to dilute and cure that adhesive during pressing. But also, very important benefit is that polyphenols inside the condensate are capturing free formaldehyde, which at the end we are finishing with, this is the particle boards with the condensate in it. We have really good results, much lower VOC emissions from the board. As I said, it's quite important thing for particle boards. And that was unexpected. The strength of these particle boards is even higher than the control ones. I don't know why, to be honest. And our third direction is agriculture. At the moment, we did some preliminary tests and something more than preliminary, and it was clearly demonstrated again that condensate inhibits seed germination of common weeds. So in agriculture, it's a long way in front of us to do field tests and all other things, but at the moment, it looks that condensate has a potential to be used as eco-friendly alternative to synthetic herbicides. Yep. Okay, that was my story. Thank you for listening.